presentation today deals with traditional Georgian singing and has two parts. In the first part, I will discuss an analysis of measurable signs of singer interaction in this music in the form of harmonic tuning adjustments. Secondly, I will report on an experiment where we try to observe the synchronization of heartbeat variability during a performance of polyphonic singing. Just to avoid any misunderstandings, the Georgia which I'm talking about is not the Georgia praised in the popular jazz standard, but the country in the Caucasus region of Eurasia, which is located to the east of the Black Sea. It is a rather small country of the size of Bavaria, but its traditional polyphonic vocal music, which is also on UNESCO's World Cultural Heritage List, is incredibly diverse. One of the most beautiful ways to experience this music is at a traditional festive meal, a so-called supra. Supras can last for many hours and involve lots of eating, drinking, ritualized toasting and naturally also singing. To give you an idea of this music, I let you briefly witness the beginning of a song about the beauty of Georgia. Our work is part of the research project Computational Analysis of Traditional Georgian Vocal Music, GVM, hosted jointly at the Universities of Potsdam and Erlangen. We are using computational methods with the hope to advance our understanding of traditional Georgian singing and how singers interact with each other. Asking Georgian singers and musicologists what they think is special with traditional polyphonic Georgian singing, I have often heard that the singers have to have vertical or harmonic thinking. Technically speaking, vertical thinking describes the phenomenon that at times singers deliberately give up the consistency of their individual melodies with a fixed melodic scale to jointly achieve particular harmonic intervals. The mechanism by which vertical thinking is realized is harmonic coordination. In other words, by jointly adjusting the intonation of the individual voices. This requires a high degree of very rapid interaction between the individual singers. In the context of our study, we make the assumption that the purpose of harmonic singer interaction is to achieve some form of acting as one entity, similar to the flocking of birds. In the simplest case, one can simulate the flocking by three simple rules for the individual birds. Fly more or less into the same direction as the flock, with more or less the same speed, and keep the distances to the neighboring birds more or less the same. So here are these three rules. To mimic polyphonic singing, we have first to reduce the size of the flock to a trio of birds equivalent to the three voices of a Georgian song. In terms of the constraints for the singers, the equivalent to the flight direction would be the melody. The equivalent to the speed would be the tempo, and the distance coordination would be coordination of the harmonic intervals between the singers. Coordination of harmonic intervals, however, is achieved by harmonic intonation adjustments. In other words, by bending the pitches of individual notes or even a whole melodic line to achieve particular harmonies. Therefore, to understand how singers interact in this flock of birds model, one has to identify harmonic intonation adjustments in ensemble recordings. This requires, however, datasets which contain separate audio recordings for the individual voices. And this is exactly what we spent a lot of time and resources on to develop within the GVM project. The first of these is the so-called Chven Mshvidoba dataset. It contains the famous Tbilisi State Conservatory recordings of the master chanter Artem Chven Mshvidoba from the year 1966. In this case, the singer sang all three voices by himself in what is now called overdubbing mode. The second one, the so-called GVM dataset, is a newly created corpus of high-quality multimedia recordings, which we collected ourselves in field expeditions in 2016 in the high mountains of the Caucasus. Here, the voice separation was achieved through the use of larynx microphone recordings for each singer, from which pitch trajectories could easily be calculated using monophonic pitch tracking algorithms. Harmonic intonation adjustments in Georgian singing happen on different timescales. Here you see two examples for rapid adjustments, one from the Erko-Maishvili dataset and one from the GVM dataset. The bottom one is extreme but nicely illustrates what happens. You can see that the bass and the middle voice move in parallel even throughout the pitch rise at the beginning of the note. This way, they jointly maintain a harmonic fifth, roughly 700 cents, throughout the 2 seconds duration of the note time window. One approach to measure these adjustments is based on the analysis of pitch fluctuations of the pitch trajectories within the note time windows. Harmonic intonation adjustments introduce statistical dependencies between pitch trajectories of the two voices, which can be mathematically quantified through the analysis of the variances of the individual pitch trajectories and their differences. In other words, if the variance of the interval trajectory is smaller than the sum of the variances of the individual pitch trajectories, the individual voices must correlate. Based on this approach, we scanned the whole dataset for notes where this phenomenon could be observed. In the top panel you see the histogram of all notes in the Erko-Maishvili dataset, which were longer than 0.5 seconds and which showed a variance reduction in the interval trajectories in comparison to the uncorrelated case of more than 50%. You can see that the intervals which are most often affected by this are the fifth, 700 cents, the octave, 1200 cents, unison, 0 cents, and the ninth, 1400 cents. Maybe even the fourth, 500 cents, but never the third. In the bottom panel you see a similar plot for a single funeral song from the GVM dataset, where again the fifth, 700 cents, is subject to intonation adjustments. These rapid harmonic intonation adjustments can be seen as skillful illustration of the harmonic vertical musical thinking of experienced singers. Examples of them are present, but not overly abundant in the GVM dataset. What is more pronounced in swan singing is another phenomenon that requires strong harmonic coordination, but on a much longer time scale. This is the phenomenon of joint continuous pitch drifts over the course of an entire song, which have been observed in particular for funeral dirges from Svaneti. Funeral songs in Svaneti are believed to be very old and to probably represent the oldest layer of Georgian polyphony. To give you an idea of this type of music, I let you listen to the beginning of one from Mestia, the regional capital of Svaneti. What happens in the course of roughly 5 minutes is quite remarkable. The whole ensemble drifts continuously and parallel upwards, similar to a flock of birds that changes direction but maintains its geometrical integrity. The red, blue and black curves show the pitch trajectories of the top, middle and bass voice respectively. The overall pitch drift in the course of the song is quite significant, namely roughly 400 cents. Closer inspection of the pitch distribution as a function of time reveals that during the pitch drift, the singers completely maintain their relative melodic tuning systems. In contrast to Western amateur choirs, where pitch drift is mostly downwards, the observed joint pitch drift in swan ensembles is nearly always upwards with similar average drift rates. Since it is most prominent in funeral dirges, it seems to serve a group purpose, in my personal opinion, to express collective pain and at the same time maintain a strong feeling of togetherness. Since during fast harmonic intonation adjustments, melodic precision is given up for harmonic precision, for example by pitch bending to achieve harmonic intervals in a particular pure way, this will have noticeable consequences for the tonal organization. In the case of the Mshvidoba and the GVM datasets, they lead to systematic differences between the melodic and harmonic scales. The main difference between the melodic and harmonic scales is fairly easy to understand if one considers that harmonic coordination aims at singing the harmonic fourth and fifth as purely as possible. To accommodate this, the approximately equidistant melodic scale, the majority of the step sizes in column 2 and 3 are not very different from 171 cents, is then temporarily bent. This then results in a significantly smaller interval for the melodic second, close to 171 cents, than for the harmonic second, which often occurs as byproduct of the popular 1-4-5 chord and is therefore about 200 cents. As a consequence, differences in melodic and harmonic scales can be interpreted as possible side effects of harmonic coordination of polyphonic singing. The second topic of my talk, which I want to briefly touch upon, is some recent and still ongoing work about the interaction of singers during performances of polyphonic music using heartbeat recordings. In 2019, during a field expedition to Western Georgia, we conducted an experiment to monitor the possible synchronization of the singer's heartbeat rates during recording session. By now, there are a few studies where this phenomenon has been observed for choir singers singing very simple songs together, and we wanted to see what happens with a small ensemble and rather complex music. Since we are usually working in very remote regions, sometimes without electric power, we also wanted to see if we could do such an experiment with very little extra hardware. During a 2-hour recording session in a cultural center in Ozurgeti in Gurian with a group of young singers, we augmented our regular recording equipment, consisting of headset and larynx microphones, by optical pulse sensors taped to the index finger of the singer. It turns out that the extraction of the heartbeats of the individual voices from cheap optical pulse sensors is pretty challenging, since the individual sensor recordings are subject to quite different amounts of high-frequency noise. After low-pass filtering, the signal-to-noise ratio visibly increases, in particular for the recording of the top voice singer. Nevertheless, the heartbeat recording quality still differs strongly for the individual singers, possibly due to differences in the individual sensor couplings. However, for all the singers, one can clearly recognize all the typical deflections seen of an electrocardiogram. Because of the fairly low signal-to-noise ratio of the pulse recordings, the extraction of a continuous sequence of heartbeats constitutes a challenging task. I don't want to go into any detail here, but we finally managed to extract continuous heartbeat recordings for all singers using predominant local pulse functions, which are calculated based on the novelty function of the signal and the tempogram. As example, I chose the Gurian song Chven Mshvidoba, which was sung close to the end of the recording sessions when the singers were well sung in. The red, blue and black curves in the top panel show the changes in heart rate for the 3 singers. The length of the averaging window is 10 seconds. The green curve shows the average singer activity for the top and the middle voice. In particular, the 2 upper voices show a clear correlation between their heart rate variability trajectories for the duration of the whole song. This means that the hearts of Gurian and Mamuka accelerate and decelerate more or less simultaneously on the timescale given by the averaging distance of 10 seconds. In contrast, the trajectory for the bass voice singer shows less amplitude variations and no clear correlation to either the middle or the top voice. For comparison, the bottom panel shows the note trajectories for the individual voices. Here you can also notice a slow continuous pitch rise of the whole ensemble, similar to what I discussed for the Swan Funeral Dirge. At this point I want to wrap up. One of the goals we tried to achieve with our study was to identify signs of togetherness in a corpus of historical recordings of the master chanter Artem Erkomashvili, and secondly, field recordings of a cappella singing of village singers in rural Georgia. If one accepts the assumption that the goal of harmonic intonation adjustments is to achieve some sort of togetherness, a variety of measurable signs can be observed and documented in Georgian traditional vocal music. Rapid, harmonically controlled intonation adjustments, continuous joint pitch drifts over whole songs, and finally we also believe that differences in melodic and harmonic scales can be interpreted as side effects of singer interaction with the possible goal to achieve harmonic togetherness or consonance on the timescale of individual notes. Our second goal was to monitor possible heart rate variability synchronization in a field expedition setting using simple optical pulse sensors interfaced to audio equipment. Here we are still at the beginning, but I feel the results are quite encouraging and suggest that there is a lot of new and relevant information to be gained in ethnomusicological field expeditions from the joint use of different sensor types. For the immediate future, we are preparing ourselves to use respiration sensors in addition. Finally, a short comment about our motivation for this study. Ethnomusicological fieldwork often deals with music which is endangered or even about to disappear. Often, simply because of logistical problems in very remote regions, ethnomusicological recordings were limited to a pure documentation of what is sung. All contextual information had to be obtained by interviews. My personal hope is that by using combinations of new sensor types such as muscle vibration, pulse, respiration, in addition to the usual video audio equipment, all of which can now be operated in field settings, the focus of ethnomusicological fieldwork can be shifted to at least a partial monitoring of more complex questions such as how singers interact during their performances. Didi Matloba, thank you very much.